Professor Stephen Hawking may have died before the James Webb Space Telescope was launched, but the late physicist's vast space legacy lives on. The new space telescope is spending a lot of time proving some of Stephen's theories. One of these theories is the multiverse theory, which Hawking worked on right before his death. What exactly is a multiverse? And what does the theory say about it? Our universe is just one of many in the multiverse, which is a vast ocean of universes. According to the multiverse theory, our universe, with its hundreds of billions of galaxies and nearly innumerable stars, spanning tens of billions of light years, is not the only one. Instead, there could be an entirely separate universe from ours. Indeed, this mind-boggling theory suggests that there could be an infinite number of universes, each with its own set of laws of physics, collections of stars and galaxies, and perhaps even intelligent civilizations. So in essence, our universe could be a small part of a much larger collection of universes. A multiverse, on the other hand, becomes creepier because it implies the existence of doppelgangers or copies. According to logic, if there are an infinite number of universes but a finite number of ways to arrange particles in each universe, the same patterns are destined to be repeated at some incredible distance, which would mean that there would be an exact copy of you watching an exact replica of this video at some incredible distance. There would be an infinite number of these exact scenarios, all occurring at the same time because there would be an infinite number of universes. Stephen Hawking died in 2018, around 3.5 years before the James Webb Telescope launched on December 25, 2021. Due to multiple delays, the launch date was pushed from 2007 to 2011. This project also gobbled up $10 billion, or roughly 10 times the original budget of the launch. However, a successful launch followed these trials. Will the James Webb Space Telescope finally prove Stephen Hawking's multiverse theory? Because of the large 6.5-meter giant mirror that had been folded during the launch, this powerful space telescope will require several months of calibration and testing before going to work. The telescope will be able to peer into the atmospheres of planets outside our solar system, as well as peer through massive dust clouds to observe the birth of new stars and planetary systems. Isn't that phenomenal? The James Webb Space Telescope will be able to collect and reflect light from the beginnings of the universes. The universe is estimated to be 13.8 billion years old, and the telescope will be able to see light from the first stars and galaxies that formed soon after the Big Bang. It's an infrared telescope, which means it detects objects in space using infrared radiation. It can also see celestial bodies that are too cool or faint to be seen in visible light to the human eye, such as stars, nebulae, and planets. According to NASA, infrared radiation can pass through gas and dust that appear opaque to the naked eye. This is in contrast to the Hubble Space Telescope, which sees visible light, ultraviolet light, and near-infrared radiation. The instruments on board this telescope must be kept at extremely low temperatures, such as minus 370 degrees Fahrenheit or lower to function. The large sun shield incorporated in the James Webb Telescope shields the telescope from the sun's heat and helps to keep it cool. According to an independent review board report from 2018, 344 potential points of failures needed to be fixed for the mission to succeed. The telescope, on the other hand, was safely launched from the European Space Agency's spaceport in French Guiana in December of last year, tucked inside the nose of an Ariane 5 rocket. After the launch, it detached itself from the rocket and began to unfold. The first deployment occurred about 30 minutes after the launch, when the solar panels were unfolded to allow the telescope to receive power from the sun. Many astronomers are vying for time with the telescope due to its capabilities. The Space Telescope Science Institute, which oversees Hubble and JWST science operations, had issued a request for proposals from astronomers on how they would like to use the James Webb's 6,000 hours of observation time. The projects of the fortunate ones have now been approved, and we look forward to the wealth of knowledge they will bring to us. With about 20 years of operation guaranteed by the amount of fuel aboard the Space Telescope, there's plenty of time for the telescope to unlock the deep secrets of the universe. Now it's time to confirm one of Hawking's most intriguing theories, the multiverse concept. The theory is noteworthy because it is the professor's last publication. His final research, titled A Smooth Exit from Eternal Inflation, was submitted for publication just 10 days before his death in a paper co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium. Despite being his final work, Hawking laid out a theory on the origin of the universe that may answer a few lingering questions. If the JWST eventually helps prove the existence of the multiverse, it will be a final look at one of his earliest theories: multiverse and the inflation theory. The concept of the multiverse appears in several areas of physics and philosophy, but the inflation theory is the most well-known example. The inflation theory describes a hypothetical event that occurred when our universe was very young, only a fraction of a second old. The universe experienced a period of rapid expansion during that brief period. Our universe's inflation is thought to have stopped around 14 billion years ago. But inflation does not stop everywhere at the same time. It's possible that as some regions experience lower inflation, others experience higher inflation. As a result, while inflation in our universe came to an end, inflation may have continued in other far-flung regions and may still be going on today. Individual universes can pinch off larger inflating expanding universes, resulting in an infinite sea of eternal inflation, containing a plethora of separate universes. Each universe would emerge with its own laws of physics, collection of particles, arrangement of forces, and fundamental constant values in this eternal inflation scenario. This could explain why our universe has the characteristics that it does, particularly properties like dark matter and the cosmological constant that is difficult to explain with basic physics. What makes our universe different? The existence of intelligent life capable of making cosmological observations, according to some scientists, is the most compelling evidence for the multiverse. Such as the longevity of stars, the availability of light for photosynthesis, and the stability of complex nuclei appear special and vital for supporting life. However, if you're given a random universe, none of these characteristics are likely to be present. The multiverse explains why all of these characteristics are favorable in our universe, by implying that other universes exist. Still, we keep an eye on this one because it can support complex life. According to Hertog, however, Hawking was dissatisfied with the state of multiverse knowledge. As a result, he invited Hertog to join him. The duo then set out to create a method for turning the concept of a multiverse into a testable scientific framework. Hawking's final paper proposes a framework for comprehending the universe that would make the multiverse finitely countable and meaningfully engageable using scientific tools. However, the theory cannot be tested if the scale of different universes in the multiverse is large or infinite. String theory, a branch of physics that attempts to reconcile quantum physics with gravity and Einstein's theory of relativity, was used by Hawking and Hertog. They devised a new concept of eternal inflation based on a boundary at the start of time. The theory proposes that tracing the evolution of our universe backward in time will eventually lead us to the threshold of eternal inflation, where our familiar concept of time will lose all meaning. The new theory predicts a finite structure of universes emerging from the Big Bang, starting from that boundary. If this theory is correct, it means that other universes similar to ours could have formed at that time, and the gravitational waves could have accompanied the expansion of the universe. However, this new model has yet to be proven, and physicists will need more data and a better understanding of string theory before that can happen. The paper also suggests that this theory could be tested, but the instruments available at the time were insufficiently sensitive to find evidence of this theory. Though in an interview, Hawking admitted that he had never been a fan for the multiverse. Strange, right? The legend who developed a field of interest to millions of people wasn't a fan of it himself. What do scientists think about it? More physical hard evidence for the multiverse's existence has been sought by scientists. For example, if a neighboring universe was close to ours, it could have collided with ours long ago, leaving a visible imprint. That imprint could be in the form of cosmic microwave background distortions. That's light from 1 million years ago, when the universe was 1 million times smaller than it is now. Meanwhile, astronomers are looking forward to a future of incredible astronomy with the massive Webb Satellite Observatory. What do you think of the Webb telescope and the multiverse theory? Will the telescope prove to be an asset in proving the theory? Let us know in the comments below. Subscribe to our channel for more videos like these, and we'll look forward to seeing you next time. Until then, happy exploring!